Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today is the 6th of April, and we will be continuing on chapter 3. Just to recap what we have done yesterday in chapter 2, we have seen a few terms that we need to understand. We have learned about system call. We have learned about what can the operating system do, and how does the operating system talk to a system call, what is a system call as per se. So that is very, very important. So today we are going to look at chapter 3, whereby chapter 3 will be talking about processes. Okay, processes. So we are going to understand the beginning, what is the difference between a program and a process. So that is the main idea you need to understand first. Okay, what is the difference between a program and a process? Okay, then we will be going on what in a process, what are the key necessary items that the operating system needs to have in order to run a particular process. Okay, and then we are also going to see examples of the process. That is very important as well. Okay, so once you get an example of the process, then you will understand how a process looks like and so on and so forth. Okay, so here's the table of contents for today. So today we are going to understand process concept, scheduling, operation, and inter-process communication. Inter-process communication means between two processes. Example of between two processes. Let's say you want to copy from the internet to your Microsoft Word. You want to copy a text. You want to copy something from one place to another place. So that is also inter-process communication. Or maybe you have between two applications. For example, let's say you are doing a transaction. Okay, you are doing a transaction on Food Panda or on Shopee, and then you want to make the payment, so you have to go to another process, which is another website, which is maybe the maybank2you.com website to do the payment. So that's two processes. And so how does operating system handle an input from one process becomes an output to another process? So that's also very, very important. Okay, so objectives to introduce the notion of a process. Okay, so a process here you can read the objective here is a program in execution. Okay, highlight the word program in execution. Okay, so look at the word here, a program in execution. Okay, so a process is something which is active, a program. Okay, so in execution, meaning to say the program is doing something. Next, we are also going to see how does the operating system schedule a process, create a process, terminate a process, or maybe you can say communicate in a process. How does the operating system communicate within a process? All right. Okay. An operating system executes a variety of programs. Okay. So we have not come to process yet. We are only talking about see the process, the programs first. Okay. In a batch system, you have several jobs. In a time-shared system, you have user program or task. So what we're trying to say here is the word job and process are almost the same, interchangeable. Okay, so even in this class, I will use the word job or process back and forth. So this definition is very important. Process means a program in execution. Point number one. Point number two, process execution must process execution must progress in a sequential fashion. What is the sequential fashion? Meaning the process needs to move from one place to another place or one state to another state. So that is a program in execution. Example, let's say you open your Microsoft Word, PowerPoint, or Excel. So before it appears on your screen, it goes through several states. Okay, it goes through several states, one after another, one after another. But what you know is you just double click on it and it appears on your screen. But what goes behind it is the operating system's job to handle each of these. So the program or the process behind it goes in, the execution behind it goes in a, it progresses in a sequential form, one after another. It cannot jump from process one, it cannot jump from progress one to progress three. It has to go through several several sequence in a sequence fashion. Okay, and in a program there are a few parts inside a program. Sorry, a few parts inside a process, because the operating system runs several processes in a computer system. Okay, get this word right first. The operating system runs several processes in a computer system. Like now, when I use my laptop, I'm running WebEx here. I'm running Microsoft, what's this, PowerPoint. Behind, I'm running a Chrome, and there's also time, and there's also the antivirus. All of these are processes. So each process inside the computer system, the operating system will run all together, but each process is different from one another. So each process is given a special ID for for the operating system to identify. Okay, so each process has a program code, which is called a text section. Okay, and it also has a counter, stack, data section, and a heap. What are all these? These are all information about a one process. Okay, each process, like I told you before, is different. Okay, PowerPoint is different, Excel is different, Chrome is different, YouTube is different. Each of these processes are different, but they are all running they are all run by the operating system. So how does the operating system differentiate one process to another process? So each process is given a special process ID. Okay, we'll come to that later. And each process has several information inside it for the operating system to know where or what is for the operating system to know something about the process. Okay, that is very important. Okay, so each process has program counter, stack, data, and heap, because each process is different. So they need the operating system keeps track of all of this. Okay, so again, program is a passive entity stored on a disk, executable file, where else a process is an active entity. Okay, so program is passive. What is passive? It does not move, and is stored on a disk, in a disk, as an executable file. What is an executable file? Well, you can see those files, you have those .exe, so those are executable. However, process is active. So once you double click on this exe file, it becomes an active program. Thus, we call it as a process. Okay. Program becomes process when the executable file is loaded into the memory. So once you double click the file, that particular program now becomes a process and it's loaded, it's brought into the memory. What memory are we talking about? It's a RAM. So let's say the program size is, for argument's sake, is 1 kilobyte or 1 megabyte. When you double click on it, does that mean 1 megabyte of the files are transferred into the memory? No. The operating system only transfers the necessary files that it needs to open up the program. all. So maybe only about 300, 400 kilobytes of the file is transferred inside the memory. Execution of programs started via GUI, mouse clicks, and command line entry of its name. Okay, so you can either, if you're running on a GUI, double click, then the program gets executed. But in a command line interface, like the example I showed you yesterday, well, in that scenario, okay, once you click the command line, then the program gets executed. Once I do any command, then it gets executed. Okay, so one program can have several processes. Okay, betul tak? One program, several processes. How is that possible? Well, you can have, for example, Microsoft PowerPoint as one particular program. When you open PowerPoint, you get document 1. So document 1 can become a process. Document 2 can become a process. Document 3 can become a process. And can these processes intercommunicate? Yes. You can copy something from document 1 and paste it in document 3. You can copy something from document 3 and copy back and paste it back to document 2. So each of these processes are are communicating between each other. Okay, but all come from one particular program. Okay, so that is why we say one programs can have multiple processes. Okay, just remember, one Microsoft Word, PowerPoint, Excel can have multiple documents. So we can say that each document is a process by itself. Okay, it's a process by itself. Okay, so this is how the files are brought inside the memory. Okay, so one program file. Okay, so one program has one process. Example here. So this process are brought inside the memory. Okay, and all of this information belongs to one particular process. So let's say we have two processes. Okay, two processes. So if you have two processes, then you will have the same thing, this same thing, two times. Okay, why do we need this? The operating system needs this because it needs to know the data, the text, all relating to that particular process. So this is very important for the operating system. Okay, so as I told you just now in previous slides, the process goes to several states, several conditions, several scenarios before it becomes a particular process. Okay, so the process goes in, or the program actually goes into several states before it becomes a full running process. So in this diagram here, it shows the state of the process. So what is the state of the process? Okay, for example, if you look at your car, when you start the car, before the car engine runs by itself, there's a process. When you push in the key and the ignition is on, there's a small step where the engine is trying to start itself. So that scenario is also a state. When you're on the stove, before the flame comes out, okay, the process of you turning the knob and the flame is coming up. Before the flame comes up, there is a process. So there are several processes before that comes here. Maybe the gas comes from the tank and the oxygen comes in and so on and so forth. Okay, before anything happens. Okay, so in operating system, in the computer system, there are several states before the process runs. So we say here there are 5 states, 5 basic important states that needs to be fulfilled before the process runs. Okay, so there is a new state, ready state, running state, waiting, and terminate. Okay, so the new state is the process being created. Okay, all of this happens in a very short period of time. So when you double click, so that's a new state created. Then you start running, that is the end of it. Okay, once you double click, the program from the hard disk is now being transferred into the ready. Where is the ready? Remember, the ready state is inside the memory. Note this down, Note this down. This is not in the notes, The new state is inside your hard disk. Okay, atau kita kata is inside your secondary memory. Okay, the new state is inside your secondary memory. The ready state is inside your RAM. Okay, RAM. The running state is inside your CPU. Okay, the terminate state is inside your hard disk. And the waiting state is inside the memory or RAM. Okay, so you have the new state. Where is the new state? It's inside the hard disk. Ready state is inside your RAM. Okay, Hidayah, running state kat mana? Hidayah. Emilia, where is the running state? Anis? Atika? Can you please answer that? Where is the ready state? Hello? 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 Can anyone hear me? Hello? Hello?
Yes, sir.
Yes, sir.
Amelia, can you hear me? Hidayah?
Can, sir.
Can you answer my question just now? Did you hear me? My question was, where is the ready state? Can anyone answer me? Hello?
RAM.
Okay. Hidayah, are you here? Hidayah? Hidayah? Hidayah?
The toilet.
You are
Hello?
in the toilet. Okay, good. All right. Hidayah, Hidayah. All right. Exactly like my daughter. Hari tu cikgu tanya pun, are you there? Are you there? Padahal she was not there. She was somewhere else. Tapi tak apa. Okay, I'll do another check. Nabila, are you here?
Yes, sir.
Okay. I just pause the class for a while. I just want to make sure. Can you all on your camera just for about a minute or so? I want to see if all of you are in class. Okay, I give you about a few seconds to on your camera. Can you please all on your camera? I just need to see all of you. All right. I can see Ashman with his long hair. Ashman, where are you? In college, ke? Ashman kat mana? Kat college ke? Kat hostel ke?
Yes.
Kat rumah?
Kat college.
College. Aiman pun kat college ke?
Semua kat college rasanya penerapan.
Okay, oh benar. Syabil, okey, semua rambut panjang. Astagfirullahalazim. Cubalah rambut macam saya kan senang. Aiman, Hanif punya rambut okey, Aiman punya rambut tepi okey. Syabil okey. Hidayah, can you on your camera? Daniel, Hanif, Hanif dah on dah. Helmi, Daniel, I can see Daniel. Iman, I can see. Okay. Haziq ada masalah sikit, but okay. Haziq, I can see. Hidayah, okay. Alright. Emilia, I can see. Liana, okay, I can see. Okay. Alright. How long have you all been in UiTM?
Seminggu.
Baru masuk ke dalam baru first sem? Baru you're semester 3 years sekarang. Shahira, can you hear me? When have you been? When did you come into UiTM?
Well, I daftar college 27.
Sorry. What I mean is UiTM Perak mean bukan hari ini mean.
This semester, my first time.
Oh, this semester. Okay, semua ni semester kiranya this is your first semester lah.
Yeah.
Yes.
And all of you are not from UiTM Perak. Ini semua penerapan hari ni.
Ada yang dari Perak, ada yang dari UiTM lain.
Okay. So yang lain tu tak nak buka kamera ke? Ada kamera. Alright, I see Shahira. Shahira, you daripada mana?
UiTM Merbuk.
Okay. Nur Fatin, where are you from?
UiTM Perak.
Sorry?
UiTM Perak. Sini juga.
Okay. Hidayah, where are you from?
From UiTM Kedah.
Kedah, okay.
Uh-uh.
Alia? Nur Alia dari mana? Aina, where are you from? Aina Khadijah.
Yes.
Where are you from?
UiTM Tapah.
Oh, okay. Okay, yang lain tu memang tak ada kamera ke macam mana? Helmi ada? Helmi? Calling. Anis, calling. Atikah, calling.
Saya punya kamera tak boleh. Dia ada
Shuhaida, Shuhaida, where are you from?
UiTM Merbuk.
Alia tadi dari mana? Alia tadi dari mana? Tak dengar tadi.
Saya daripada UiTM Merbuk.
Okay. Fatin, are you there? Helmi, okay, I can see you. Bilik berterabur. Mas dari mana Cik Mas?
Dari bahasa.
Okay. Daniel, where you from? Daniel Azrul,
Yes, sir. Daripada UiTM Kedah juga.
Kedah juga. Okay, Haziq dah. Afif Fahmi, Fatin, Atikah, Nabila, Atikah Zulkifli. Can you hear me?
Yes, sir.
Where you from?
I'm from here, sir. UiTM Tapah.
Oh, you from Sabah. Awak pun duduk hostel juga?
Yes, sir.
Okay. Syahi Helmi, okay, I can see Helmi. Daniel ada kat situ, okay, very good. Atikah missing, Fatin missing, Zulaika missing, Dina, Dina missing, Alia missing, Nabila missing, Afif missing. Anis, tadi macam ada Anis.
Kamera ada problem lah, saya tak
Yes, betul, kamera memang problem. I understand. Okay, never mind. I just want to see your face sebab macam Fatin ni saya tak tahu mana kita unmute Fatin. Fatin, are you there? Fatin. Afif, are you there? Cik Afif. Cik Nabila, are you there?
Yes, sir.
Nabila punya kamera rosak ke? These things happen. Okay. Cik Dina, Cik Dina, are you there? Dina missing. Cik Zulaika, are you there? Missing. Okay. Alright. Okay. For those yang I called their name and they are missing, just please send my regards to them lah. Sampaikan salam sayang kepada mereka. Sampaikan salam sayang saya kepada mereka dan ucapkanlah selamat berpuasa kepada mereka. Dan I like to have their names in class walaupun kita assume yang mereka-mereka macam contohnya Fatin, Atikah tadi macam ada, Fatin, Afif tadi macam ada, Afif pun tak ada, macam Nabila dan rakan-rakan seperjuangan yang tak respon ni, kita assume kamera mereka dan juga mic mereka rosak. Okay, so we assume that they are there and they are not eating. Mungkin juga mereka tengah makan, so kita tak bolehlah kacau orang makan kan. Okay, soalan kedua saya, Daniel Azrul.
Yes, sir.
Dah bersedia dengan soalan saya?
Bersedia.
Malam nanti makan apa?
Apa dia?
Malam nanti makan apa?
Malam nanti makan nasi dengan ayam goreng ke?
Oh, sedap. Saya dengar ada pasar Ramadan di di kampus
Betul.
Is it nice? Sedap ke?
Saya pergi waktu first day je, tu pun 4 bazar. Yang second day sampai semalam saya tak pergi. Tapi katanya dah banyak lah buka. Tak tahulah banyak mana.
So kalau awak tak pergi, awak makan kat mana?
Saya bungkus kat kafe.
Sembahyang tarawih pergi?
Sembahyang tarawih tak pergi.
Okay, bagus. Satu orang kata satu convention bagus. Kita cuba pergilah.
InsyaAllah.
Okay. Alright, thank you so much for owning your camera. I just wanted to see. So mereka yang tak respon saya tu, you make sure awak sampaikan salam sayang pada mereka. Katakan pada mereka yang yalah, cakap saya sayang pada mereka lah. Just say that. Okay. Alright, thank you so much. Now we continue back our lecture. Okay, so kita dah tahu. Okay, we know now that Daniel is going to eat ayam goreng tonight. Okay, so that is nothing to do with this chapter. Tapi itu hanya sekadar selingan. So every now and then, I hope that you respond to my questions. Okay, you respond to my questions and you respond to my when I ask you any questions. Okay, right. Come on. Okay, all right. Now let's continue. So when you double click your program, so that program is now being transferred or now is becoming a process. Okay, so this transition from a program to a process goes through several states. Okay, so it starts from the state called new, running, waiting, ready, and terminated. So the new state here, the first state, is inside your hard disk. Okay, it's inside your hard disk. So once you double click on it, the program now is being admitted, put inside the ready state. So the ready is inside your RAM. Okay. Once there is an empty spot inside the CPU, inside the CPU, the operating system gets the process from here and puts it inside here, inside the RAM. So now the process is inside the CPU, is now being run. Okay. So how or who carries the process from here to here is the operating system has a dispatch. A dispatch is a software, okay, is a software, yes, it's a software inside the operating system to carry the process or to bring the processes from the RAM to the CPU. Always remember, in the CPU, there can only be one process running at one time. Okay, so now in my CPU, in my laptop, there is only one process, but there can also be multiple processes, but all of the processes will take in a certain period of time. Okay, right. So now the process is brought from the ready to the running. Once the process is terminated, when I shut down the process goes back to the hard disk and is now called terminated. Okay, terminated. So your hard disk. Okay. The process can also from your CPU go inside waiting. Example, let's say you are printing. So printing is a process. However, the printer has is running out of paper. Okay, so it goes inside the waiting state. Okay, so the waiting state, the process inside the waiting state is inside the RAM. Okay, it's inside the RAM. So the waiting state is also inside the RAM. Once the process has been once you put in the paper or the input output comes, okay, back on, now the process goes back to ready and goes back into run. Okay, so always remember there are 6 states: new, running, waiting, ready, terminated. New, running, waiting, ready, terminated. Sorry, 5 states: new, running, waiting, ready, terminated. So you need to remember all of these states and you need to know where are these states. The new state is inside your hard disk. The ready state is inside your RAM. The running state is inside your CPU. The terminated state is inside your hard disk as well. And the waiting state is inside the RAM. The schedule dispatch here is a type of software inside the operating system which brings all of the processes from the RAM, the ready state, into the running state. Okay. As I told you just now, there are so many processes running at one point of time. Okay. So each process inside the RAM will be brought into the running state. Who brings it is the dispatch. Okay, scheduler dispatcher brings all the processes from the ready to the run. That's his job. It's a type of software inside the operating system. Okay, so next we go into process control block. What is process control block? Process control block is how each process is identified. Okay, how each process is identified. So each process has something called a PCB. Okay, so if there are 5 processes, so we have 5 PCBs. So each PCB has all this info inside: the process state, counter, CPU register, CPU scheduling information, memory management, accounting, and input-output information. Why is this information important? It is important for the operating system to know what kind of process it is, what kind of files it needs, what is the current state of this process. So each process will have a process control block, and inside the process control block there will be these information. So why are these information important? To know what is the current state of the process, what type of files is needed, and what is the registers or so on and so forth is being used by the particular process. So remember, these are very, very important. So each process has its own PCB. So as we said, one program can have multiple processes. Okay, so if we have Microsoft Word, one program, document 1, one PCB, document 2, another PCB, document 3, another PCB. Okay, so in this diagram, it shows how the CPU switches from one process to another process. Okay, what does that mean? Simply, okay, it means like you are running Microsoft Word, but how do you suddenly move into Microsoft PowerPoint or PowerPoint from Word? How do you move to PowerPoint? Well, there is something called an interrupt that switches, okay, the process from PowerPoint to from Word to PowerPoint. Okay, there's an interrupt. Okay, an interrupt happens. So what does the CPU do, or what does the operating system do? Okay, let's say you are running in Microsoft Word document. So Word document has its own PCB. So when you switch into PowerPoint, which has a different PCB, the operating system saves the current PCB, okay, saves the current state, and reload balik. It will reload the PowerPoint punya PCB. Once it's finished, then it will reload balik the Microsoft Word punya PCB. So where are all these PCB kept? The PCBs of each process is kept inside the memory. Okay, inside the memory, inside the RAM. Okay, inside the CPU, inside the running state, there can only be one process. Only be one process. But then there will be question lah. How is that possible? At this moment, I'm looking at PowerPoint and I'm running WebEx, or sometimes I do my Microsoft Word and I'm listening to YouTubes. How is that possible? Well, the CPU runs at a very, very high speed, and the process is interchangeable between two processes. So the operating system keeps changing each process inside the CPU. Okay. Okay. Next, we also have threads. Okay. So so far, what have we learned? We have learned about program and process. Program and process, program and process. So we said that one program can have multiple processes, correct? Now, if you go into threads, threads are sub-processes. Okay? So far, process has a single thread of execution. A thread is a separate flow of execution. This means that your program will have two things happening at once. Okay? Consider having multiple program counters per process. Then you will have multiple location can execute at once, multiple threads are controlled, must then have storage for thread details, multiple program counters in PCB. Okay, what does that mean? Meaning, in previous slide we said satu program, one program, multiple processes. That's quite simple. Okay. Now, in one process, you can have multiple threads. Okay, multiple threads. So what is the meaning of this? What is the meaning of threads? Okay, simple. A thread means a sub or a separate flow of execution within that particular process. Example, okay, let's say you are running your Microsoft Word. Senang je, you are running at Microsoft Word. Okay, when you run your Microsoft Word, let's say you have typed in about 10 pages and you want to print, so you print. Okay, that particular process inside a process is called thread. So the process of you printing is called thread because it's a separate execution, but it's all within the process. Okay, so when you click command print, the print execution can go on and you can continue doing your Microsoft Word. Okay, that is an example of thread. But let's say while printing page number 5, tiba-tiba there is a problem, so the thread can inform the process, there is a problem as well. Okay, all right. So a thread belongs to one process. So a thread also has its own PCB. Let us assume, okay, let's say you have typed in your Microsoft Word process number 1, 10 pages, and then you print. So print is a thread. And then you accidentally close the program or end the Microsoft Word. What then happens? If you end the whole process, if you suddenly shut down your PC, then automatically each process is all shut down and it's up. That means process Microsoft Word pun shut down, the threads inside it pun shut down. Okay, but if you close one thread, let's say you want to print, tiba-tiba tak jadi print, so you close the printer punya menu tu, your process will still be running. Okay, the thread only shuts down if the main process is shut down or the program itself is shut down. Okay, so a thread, point number 2 here, a thread is a separate flow of execution. This means that your program will have two things happening at one time. Okay, so Microsoft Word and print. So Microsoft Word document 1, 2 is a process, and you print, that's a thread. If you have any questions, please ask. All right. I think we shall stop here because this is a bit more detailed, 3.2, and we should continue in the next class. Okay? Because this is a bit tedious to explain, so I'll explain to you in the next class. All right? So I hope that you have take notes of my lecture, and I hope to see you in the next class, which is next week. Okay? Do you have any questions to ask me? Are you all okay? Okay.
Okay, sir.
You're good. Okay. So inshallah, I will see you in the next class, and make sure if I call your name in the class, please respond. Okay. So for those who have responded on your video today, very, very good. I give you peace. For those who have not responded, I have no idea why. I'm assuming you're either eating, your camera is not working, your mic is not working, or you're just not here. Okay? All right. Thank you so much. Inshallah, I will see you in the next class. Assalamu alaikum warahmatullahi wabarakatuh.